Local minima and local maxima. A function f is an increasing function on an open interval if the output of b is greater than the output of a for any two input values a and b in the given interval where b is greater than a. Now, a function f is a decreasing function on an open interval if the output of b is less than the output of a for any two inputs values a and b in the given interval where b is greater than a. Now, a function f has a local maximum at x equals b if there exists an interval a to c where b is in between the values of a and c, such that for any x in the interval, we can say that the ordered pair a, c, the function f of x is less than or equal to the output of b. Likewise, f has a local maximum at x equals b if there exists an interval a to c with b being in between a and c, such that for any x in the interval ac, the function is going to be greater than the output for b. Now, for example 7, we want to find increasing and decreasing intervals on a graph. So given the function p of t in figure 6, we want to identify the intervals on which the function appears to be increasing. Okay, so I'm going to go ahead and then put in negative infinity on the left and then positive infinity on the right. It's just important to make sure that you make note of that. And so what we want to do is we want to figure out, okay, what's happening with the graph where it's increasing and decreasing. Okay, so if we go from left to right, it is increasing from here, decreasing from here to there. And then at 1 here, it's then going to increase. And then it's going to decrease again. And then it's going to increase. Okay? So what we want to do is we see that the function is not constant on any interval. And that means there's no horizontal flat line. Now the function is increasing where it slants upward as we move to the right and decreasing where it slants downward as we move to the right. Now the function appears to be increasing from t is equal to 1 to t is equal to 3, and from t is equal to 4 and on. So in interval notation, we would say that the function appears to be increasing on the intervals 1 through 3 and on the interval 4 to infinity. So let's just go ahead and then take a look at both the increasing and decreasing part. So we can say that it is decreasing on what intervals and increasing on what intervals according to our graph. Well, since it's starting at negative infinity, okay, it's decreasing until it gets to 1. So we know that one of the intervals is going from negative infinity to the value of 1, and that's where it is decreasing. Okay, where else is it decreasing? Well, it starts at 3 and it's going to 4. So that means it's also decreasing here. So it's decreasing between 3 and 4 as well. Now, if we want to figure out where it's increasing, well, let's take a look at that interval. So from here to here, we can see that it is increasing. So between 1 and 3, we know it's increasing. And then over here, we're going from 4 all the way to infinity. And it's increasing there. So we know it's increasing from 4 to infinity. So notice in this example that we used open intervals, intervals that do not include the endpoints, because the function is neither increasing or decreasing at t is equal to 1, t is equal to 3, and t is equal to 4. So these points are the local extrema, meaning the two minima and maximum. So let's take a look at the ordered pairs here. The ordered pair here is 3 and then 1. The ordered pair here is 1 and negative 1. So we can say that the local maximum occurs at the y value, which is 1, at x is equal to 3. And then over here we can say that the local minimum occurs at negative 1 at x is equal to positive 1.